Today we're going to talk about molar mass. For this lesson, you're going to need a periodic table, a calculator, and your follow-along notes. So let's talk about what molar mass is. It's the mass of a mole. So before we get into that, let's talk about the mass of a dozen. If you have a dozen cookies and you put it on a scale, is that going to be the same mass as a dozen cars? Probably not, because one cookie and one car don't have the same mass, so if you put it on the scale, even if you have the same quantity of them, it's going to have a different mass. Well, same with our atoms. Every atom has a unique mass, and that's shown to us on the periodic table. So the mass of one mole of an element is found on the periodic table as the average atomic mass. Remember, this had to do with different isotopes, different number of neutrons, but luckily we're finding all those different types in any given sample. So go ahead and find carbon on the periodic table. What's the mass of one mole of carbon? Well, what's the atomic mass? It's 12.0, but now we use grams instead of atomic mass units because we're talking about a lot of them. So we're talking on the human scale. How about the mass of one mole of magnesium? One mole of magnesium, go ahead and find magnesium over there on the left-hand side of your periodic table. You'll see that it has the mass of 24.3 grams. So if you have 24.3 grams of magnesium, you know you have one mole of magnesium. In that one mole, you have 6.02 times 10 to the 23rd atoms. How about one mole of copper? Go ahead and find copper. It's a transition metal in the center of your periodic table. And it's 65.3 grams of copper. Notice for this, I'm keeping one decimal place. It's really important that you do your rounding properly and go to one decimal place so we all have the same answers. Different teachers might want different numbers of units, but I like to go by one decimal place because pretty much all periodic tables go to at least one decimal place. That way it's pretty universal. Let's talk about the mass of one mole of a compound. So the mass of a compound comes from the masses of all the moles of the elements that make up that compound. So for example, if we have 1 mole of calcium chloride, remember in calcium chloride, there's going to be 1 mole of calcium and then 2 moles of chlorine to cancel out the positive 2 that came from calcium. Each chlorine has -1. So 1 mole of calcium chloride, the whole compound, is made up of 1 mole of calcium atoms and 2 moles of chlorine. And that comes from the subscripts. See how there's nothing here, so it's a 1, and there's a 2 here, so there's 2 for chlorine. So the molar mass of calcium would be 1 times calcium plus 2 times chlorine. Then you look in your periodic table and plug them in. That's 1 times 40.1 and 2 times 35.5. This gives you 111.1 grams per every 1 mole, or just grams per mole, of calcium chloride. Let's do another one. Let's talk about the molar mass of ammonium sulfide. This is going to be made up of 2 moles of nitrogen, 8 moles of hydrogen, and 1 mole of sulfur. Now, how did I get 2 for nitrogen and 8 for hydrogen? Well, this 2 on the outside of the parentheses gets distributed into everything inside the parentheses. Remember, it's only for things inside the parentheses. So this nitrogen, which had a 1, becomes a 2. Hydrogen that had a 4 becomes an 8, because you have 2 of this whole thing. So then we have 2 nitrogen plus 8 hydrogen plus 1 sulfur. Plug in your molar masses. Nitrogen is 14, hydrogen is 1.0, and sulfur is 32.1. Plug this into your calculator, a real calculator, don't use your cell phone, and you'll get 68.1 grams per mole of ammonium sulfide. Okay, now it's your turn. Go ahead and freeze the screen. Try and solve the molar masses for nitrogen, dicarbon tetrachloride, magnesium carbonate, and strontium hydroxide. All right, here are the molar masses for each of these now that you've worked it out on your own. If you had any trouble with these, go ahead and grab a teacher. Good luck solving part 1 of your worksheet.